very, very basic, and then we'll crank it up from there. We'll see how that goes. Would you please take a minute, please graph this function, shade in the area that we're even talking about, and actually come up with the exact value of the area using the antiderivative, the fundamental theorem of calculus. So go ahead and take a minute, please. Graph it, shade in the proper region, and actually find the area of the region of interest. If you're struggling with this integral, then Thursday is going to be a nightmare for you.
I already know that.
Fair enough. All right, so in this case, integral of x squared dx as x goes from 0 to 2. Let's see what the graph looks like.
1 to 2.
What did I say?
0.
1 to 2. Thank you. Right, just a piece of the parabola. And here's my area of interest. And we're a little bit more sophisticated than years ago when they only had numerical solutions. Thanks to Newton, who created calculus for us. He said to do this, we can use the power rule. That's going to be exactly 7/3 square whatever if we're looking at area. We okay? So what we're going to do is we're going to numerically start calculating this out. Our ultimate goal is to see how close to this we can get. So if I change this to a decimal, just so we have an idea, this is going to be 2.3 bar, right? That's what we're shooting for. We want to see how accurate we can make this. So let's do upper rectangular. Now, your Calc 1 teacher should have gone through some of this with you. Now, if we do upper rectangular, in this case, that's going to mean that we're going to have too much area. Now, I'm going to say let n equal 4. We'll keep it nice and basic. Meaning, I'm going to break this up into 4 pieces. I'm sure you all remember this. Delta x equals b minus a over n. going to be what in this case? What's A in this case? 1. What's B in this case? 2. And N in this case is 4. Meaning this is my step size. This is how far I get to step each time to make a new rectangle along the x-axis. Next step. Find the nodes. Your other teacher may have called it something else. I is a counter. Starts at 0, goes up to n. Now, since this is your first brush with numerical analysis, our node points are all going to be the same, meaning distance the same. In higher mathematics, sometimes we're really interested in breaking it down over certain spaces, and other spaces not so much, so we can make it uneven. But for now, everything's going to be even. So here are my node points, node values. What's A in this case?
1.
1. We got to keep that in mind. X naught is always A. X sub n is always B. I'm going to let you fill in the rest. I'm actually teaching this lecture quite a bit differently than I have in the past, so you guys are getting a different way. Hopefully a different way.
Streamlined.
What's that?
Streamlined.
Yeah, we'll see. A little bit more all-inclusive. Do you see they're exactly 1/4 away from one another? Yeah. Again, your endpoints, your x naught and your x sub n should always be your A and your B.
Oh, okay.
There's my nodes. And again, note my delta x is exactly, they're supposed to be even. I know it's not drawn perfectly, but you get the idea. Questions so far? This skill that we're doing here is going to apply to pretty much every method that we're doing. We're going to learn a total of